And then here, O plus. This is difficult to write with this. And then,
I'm sorry, I didn't know it would be that much work.
no, it's because I'm not used to writing like this with this weird pen, you know? Okay, so this would be, let's say we have y plus here. Okay, let me erase then what I put here. It's not a problem. Okay, so let's look at this. Let me get the pen. So now we have, I forget, let me erase that other thing there because, what is that? Looks weird. It's confusing what I have. So, I don't know at all. How do I get this out of the way? Okay, let me see. What did I, okay. Oops. Okay, so now we have, let me get my pen. Lac I plus over lac I plus OC, O constitutive over wild type operator, lac C plus over C plus, lac Y minus over lac Y plus. Okay, so with or without inducer, you have constitutive expression of beta-galactosidase because by the fact that you have a dominant mutation here regulating this operon on this strand or this duplex of DNA, so you have plus plus. Okay, this affects only that, so you do not have expression of permease from this duplex, but you have this here. You have a wild type repressor, so without inducer, you have no permease. But if you add inducer, then you are able to express because you cannot bind the repressor here. You're going to have permease, and you're going to have inducible permease, and then you're going to have growth on lactose. Is that clear?
Yeah, definitely. When you look at growth on lactose, would you include like positive but with an inducer? Because it's not always growth, right?
Well, it is growth on lactose, so it has, because in order to use lactose, remember you have to have both permease and beta-galactosidase. So both of these columns, something has to be positive in these columns, okay? In order to have a positive here.
Okay, cool. Thank you.
Okay, so Sandra, do you want to do this one, number 9? Okay, let's see. Okay, Hamse, do you want to do this, number 9?
Okay, I'll try.
Well, we are all trying, so
Okay.
that's the part that is important. Okay.
So is it going to be the first two minus minus? Because of then the next one is going to be plus.
Why is that going to be plus?
I said that because of lac Y minus, and you have the repressor is going to be also positive there, or does it matter for the repressor? Because look at the promoter. Yeah, the promoter.
What is the promoter?
So.
What is the function of the promoter?
Oh, that's where the RNA polymerase.
Do you have a promoter?
No, you don't.
So are you able to express anything here?
No, so it'll be minus minus. Genes are turned off for this one. Okay. So minus.
See, you ignore the promoter. You cannot ignore the promoter. Okay, so you have to pay attention to this minus here. That gives you a clue. Nothing here. Whether you have positive, negative, is not going to be expressed. It doesn't matter. There is no repressor. Period. It doesn't work.
Okay.
Okay, and this one, obviously you don't know unless you read the assignment, in the textbook. So you have a very interesting um, repressor mutation, that is the LAC-I S mutation, and this is S stands for super repressor, not suppressor, super repressor. That is a repressor that is blind to the inducer, because as you see in the reading assignment, there is in the way the repressor falls, there is a pocket where the inducer binds and to inactivate it or change the conformation. But this particular mutation has a mutation there and it cannot bind any inducer, no matter what the inducer is. So it's blind to inducer is always going to be negative, okay? It's a dominant mutation. Transacting and dominant, because it's a repressor mutation, so it will bind to any operator as long as the operator is wild type. If the operator is constitutive, then that is another story that I'm going to let you think about. But obviously you didn't know this, and I wanted to tell you, but it is mentioned in the book. Okay, so it doesn't matter if everything is positive. It will always bind the operator, the wild type operator. So there's no way the RNA polymerase is going to get to the promoter, and so it's negative. Okay, are there any questions? Now you need to make sure that when you do, I can try to put after the exam more of these examples where you have more merrodiploids, and you have to look at that diagram that I gave you where you have with inducer, without inducer. You have to draw some of these merrodiploid lines yourself, okay? You have to do it on your own. Don't try to do it in your head, because it's going to be very confusing if you do it in your head. Once you do a few of those, you are really going to catch very quickly, and you start seeing the picture, very clearly. So are there any questions about that problem set?